Okay, your final exam is going to be a big one, so don't blow it. Make sure you study hard, good notes, do your best. So the first chunk is factoring. The 500 club, we've done a bunch of them. Still have 1,000 more to go till you're proficient. But so there's all sorts of types. Move number one. If you come across a polynomial, always try and shrink it down. See if you can find a common factor and divide each of the terms out. So 5n squared, 65n, 150, you can divide them all by 5. So that's got to be your first move. If you can shrink them down, do it. So it is going to be written as 5 times, divide each of the 3 by 5, and the leftover is just 1n squared minus 65 divided by 5. It's going to be 13 n's plus 150 divided by 5. That is leaving you with 30. Okay, now once you do that, see if you can keep going. See if you can go again. So I'm going to factor this polynomial down, and it is, your a is 1, your b is negative 13, your c is 30. Anytime your a is 1, let's see if we can find something that will times to give you 30 but add and give you a negative 13. And the two integers that multiply to give you a 30 and at the same time add to give you a negative 13 are a negative 10 and a negative 3. And if you can find integers that times and give you 30, add and give you negative 13, times and give you the c, add and give you the b, then we're going to write it just like this. n minus 10 minus 3, and that is the factored form of 5n squared minus 65n plus 150. Okay, number 2, try and shrink it down. 2 and 15 and 25 got nothing in common, so it is shrunk down as far as it's going to go. Your a is 2, your b is 15, your c is 25. Okay, now it ends, the c is a perfect square. We can do square root of 25, but we cannot do square root of 2. So if you can't shrink them down, see if they're perfect squares. If they're perfect squares, they're actually easy, but this is not. So this is actually the hardest. This is the worst type to factor. And here's how we're going to do it. We are going to copy and paste 2m squared plus blank plus copy and paste 25. Now the 15m, we are going to break that into 2 terms. So they've got to add and give you 15m. And we know this. We know that the very first times the very last is the same as the middle times the middle. So 2m squared times 25 is 50m squared. So the middle times the middle will also be 50m squared. So now I can use this template. Here's what I'm looking for. I'm looking for something that multiplies to give you 50, but it's got to add to give you 15. And everything is positive, so we're going to go with a 10 and a 5. So 10m and 5m will times and give you 50m squared, which is the same as the first times the last, but it will also add to give you the middle, the 15. So we're going to go 10m and 5m. Okay, so if your a is not 1 and it is not a perfect square, then we're going to take this trinomial and we are going to rewrite it. You're going to break up the middle term into 2 pieces so that you got a polynomial with 4 terms. And now once you got 4 terms, you're just going to group them. So this first group, take the GCF out, divide that by 2m, and it will be 2m times m plus 5. And your second group, divide that by 5, and it is 5 times m plus 5. And then now you've got 2 terms. I'm going to divide those by the GCF, divide that by m plus 5, divide that by m plus 5. Your final answer is going to be m plus 5 multiplied by the leftovers, 2m plus 5. So these are the worst type. These are the hardest. Number 3 is a special case. Move number 1. Divide it down. You can divide 45 and 80, divide them both by 5. And if we do that, we have 5 times 45 divided by 5 is 9. X squared minus 80 divided by 5 is 16. Okay, now this one, you're actually missing this. So your A, if we're looking at this one, we only have 2 pieces instead of 3, and the piece that we're missing is the middle piece. You're missing the B. You're missing the piece with the letter. So for an ABC, if I'm looking at this guy right here, my A is a 9, my B, I don't have one, and my C is a negative 16, and these, A is not 1, but it is a square root, and C is a square root, so this is actually a special case. This is going to be easy. So I'm going to factor it. I'm going to break this down into 2 groups of parentheses, and how you times to get the 9x squared, you just square root it. So we're going to go 3x and we're going to go 3x. And then the square root of 16, that's going to be 4 and 4. But it's a negative 16. So one of them must be positive and one of them must be negative. And because they're the same thing, one's positive, one's negative, these are called conjugates. That's how you get the middle to zero out. So 3x times 3x gives the 9x squared. 3x times a minus 4 is a minus 12x. 4 times 3x is a plus 12x. And that is 0. And 4 times a negative 4 is minus 16. And there we go. Okay, let's do 3 more. 2p cubed minus 3p squared minus 16p plus 24. So you got 4 terms. None of them are like terms. You can't add them up, combine anything. So we're done. Now, 4 terms. Let's just group them. Let's group these 2. And let's group these 2. So out of your 2p cubed and your minus 3p squared, the greatest you can take out is just a variable. They both have p's. So take p squared out of each. So if you take p squared out of each and you divide, you're left with 2p minus 3. Okay, now this group, you have to take the negative with it. So it's negative 16p plus 24. Okay, I'm going to divide as much as I can. I can take I can take 4, but there's something even bigger than 4. You can take 8. Actually, 8 will go into both of them. So if you divide both those by 8, it is going to be 8. A negative 16p divided by 8 is a negative 2p. And 24 divided by 8 is 3. Now, if you start looking at group 1 and group 2, they're almost identical. This is a 2p minus 3, and this is a minus 2p plus 3. And I want it to be 2p minus 3. So don't divide by 8, divide by, if we're going to change the signs, if you divide by a negative 8 instead, that will change the sign. Because a negative divided by a negative is positive, 24 divided by a negative is negative. So it's a little manipulation. You can match it up just like you want it. Then your final answer, one of the groups you're going to have this common 2p minus 3, and your other group you're going to have a p squared minus 8. And that is it. Okay, the next one, 16n squared minus 40n plus 25. You can divide that by 5, but you cannot divide that. But your A is a perfect square, and so is your C. Your B, don't worry about your B. If your A and your C are perfect squares, then chances are it's going to be easy. So let's factor it. Let's just take the square root of 16n squared, and that is 4n and 4n. Square root of 25. Oops. That is a 5 and a 5. And the sign, they have to add and give you a negative 40, but they got to times and give you a positive 25. So it's going to be a negative, negative. And this is a perfect square, it's a double. Now where the 40 comes in is right here. 4n times 4n, that's your 16n squared. 4n times a minus 5 is a minus 20n. A minus 5 times another 4n is another minus 20n. And a minus 5 times minus 5 is a positive 25. There's your minus 40. So if your A and your C are perfect squares, that's a special case, likely, and not too bad. Okay, the last one, so it looks like it's already shrunk down as far as it's going to go. Your A is a 1, and we love that. That's usually the easiest. B is a negative 5, C is a negative 24, so you can use your template. Do there exist numbers that times to give you a negative 24 while adding to create a negative 5? And you can play around with 8 and 3, and it's got to be a negative 5, so the 8 has to be negative. A negative 8 times 3 is a negative 24. Negative 8 plus 3 is negative 5. So then, here we go. N minus 8, n plus 3. Not too bad. Okay, now, then we went on to introducing kind of two forms. So standard form, make sure you have this in your notes. Standard form is the a first, ax squared, plus the bx, and the b is how many linear pieces you got, and then your c is the number, the constant, so there's no variables with it. Uh-oh. Okay, then we introduced vertex form, and vertex form is way easy to graph. Vertex form is y equals a parentheses x minus h squared plus k, and this is a perfect square. And you got to remember, there has to be a minus in the model, and h is always after that minus, so h is kind of always opposite what you think it's going to be. So 4, you got to find abc and then ahk. So they're giving 4 in standard form. So your a is how many squares you got, so a is 1. B is how many x's you got, and you have to take the minus with this, so it's negative 20. And c is the number with no variable, so c is 2. So pretty easy, but the ahk, that's going to take a little bit of manipulation. So you're going to have to kind of transform it. So you got to factor it. It's got to be factored, and it has to factor to a perfect square. So right now, c is not a perfect square. And if I try to factor this, there is really nothing that's going to times and give you 2 and add and give you a negative 20. I mean, nothing. There is something, but it's not an integer. So here we go. You're going to use a method called completing the square. So you're going to take the x squared minus 20x, and you're going to create your own c. So the c they gave you, we just scoot over, plus 2. So if I could have any c of my choice, and it's got to be a square. It's got to be a perfect square. So 4, 9, 16, 25, 36, 49. The square you want is 100. And how you complete the square is you take whatever b is and you cut it in half, and then you times it by itself. This is the template you use to complete the square. So negative 20 cut in half is a negative 10, and a negative 10 times itself. That's how I got the 100. So if I add 100, I just changed the whole equation. So you have to actually add 0. Add 100, take away 100, that is 0. These three play together, and they will factor, to give you what times is to give you 100, adds to give you a negative 20, and that is a minus 10 and a minus 10, and that's a double. By design, you created that to be a perfect square. That is x minus 10 squared. And then these two play together. A minus 102 is a minus 98. And now without too much work, we converted it to vertex form. Vertex form, your A is the number outside the parentheses, so if there's nothing, it's just a 1. H is after the minus, so our H is actually a positive 10, not a negative 10, and then K is out here. K is a negative 98. So that's not too bad. Okay, number 5. Let's look at 5. 5 is given to you in vertex form. So your A is actually 3, and A is the same in both, either way, standard or vertex. A is always A. It's the same thing. Okay, H is actually a positive 4, not a negative 4, and then K is 3. And this one actually might be a little bit easier to convert from vertex into standard. So if you've got 3x minus 4 squared plus 3, you're just going to work backwards. So the step before this was it factored to a double, x minus 4, x minus 4. And then the step before this, we multiplied through to find what polynomial that was. That double is x squared minus 8x plus 16 plus 3. But then you gotta times each of these terms, each of these 3 terms in the parentheses by 3. So it is going to be 3x squared minus 24x plus 16 times 3. Well, 16 times 3, 48 plus 3. And now these are like terms, so you can combine those like terms. So you got 3x squared minus 24x, a 48 and a 3. Those are a total of 51. Okay, now you got it. So your A is 3, B is actually a minus 24, and C is a 51. Okay. Whoops. Okay, we got 4, 5. Alright, 6 and 7. Now let's graph them. Remember, you gotta have 5 points. So g of x is a translation of 2 units left, 2 units down of f of x. Okay, here is f of x. So let's just graph f of x. F, I've got a is a negative 2. H is actually not a positive 3. H is a negative 3. And k is a negative 2. Okay, now if I graph that, this is actually an easy question, but you read it and it kind of looks intimidating and looks hard, but it's not bad. So first, let's just see what this looks like graphed. So your first dot is going to be left 3 and down 2, so right there's your vertex. Okay, now I need 5 dots, so I'm going to just start plugging dots into my equation for x. I'm going to plug them close to negative 3, so I'm going to try a negative 2 and a negative 1. So if I do a negative 2 in here and just type that in your calculator and hit enter, it should give you a negative 4. So that means this: if I go left 2 and down 4, 1, 2, 3, 4, I get a dot there and I get a dot there. And if I plug in a negative 1, and just type it in your calculator, negative 1 plus 3 is 2, 2 squared is 4, negative 2 times 4 is negative 8, negative 8 minus 2, that should be negative 10. So left 1 and down 10, so there we go. This is f of x. Now, they want you to translate it. So they want you to slide it, flip it, rotate, who knows. So we are going to translate, so that's a slide. We're going to slide 2 times to the left and 2 times down. So if I just take this vertex and go 1, 2 to the left and 1, 2 down, there we go. And then these dots, take them each 2 to the left, 2 down, we got 1 there, 1 there. Pa-boom, pa-boom. So it's going to look like this. Now, G is the new one. This is G. So the question is, can you write the equation of G? what is my A, what is my H, and what is my K? So your A is the slope. We did not change it, so this A was -2, so this A is going to be -2. H is how far left we're going to go, and we, from 0, we're going to go 1, 2, 3, 4, 5 left. So H is -5. And K is how far up and down you went. And we went 1, 2, 3, 4 down, so it's -4. So your model is going to be A, which is -2, parentheses, x minus h, which is a -5 squared, plus k, which is a -4. And this minus is part of the model. That minus is -5 because I went 5 left, and you could either leave it or write that as plus. And there we go. So that's an awesome question. Okay, 7. Take this equation, y equals x minus 2 squared. So let's graph this first. A, H, and K. A is the number in front, which is just a 1. H is after the minus, H is 2. K is not there. So K is some number outside the parentheses. So here we go. If I'm going to graph this, my X is left and right, which is the H, and Y is up and down, that's your K. So my very first dot is going to be over 2 and 0. Okay, now let's try something close to 2. Let's try like a 3 and a 4. So if I take 3 in here, 3 take away 2 is 1, 1 squared is 1. 3 should give you 1. Over 3 up 1, so I got 1 there, I got 1 there. Because this vertex is the very dead center. Then try 4. 4 take away 2 is 2. 2 squared is 4. 4 gives you 4. So go over 4 and up 4. So there we go. So here we are. Okay, now let's transform it. So here's what you gotta do. You gotta reflect it over the x-axis and then slide it 4 times left. So if I go 4 times left, 1, 2, 3, 4, and then flip it over the x, it's gonna look something like this. So my new A, my new H, and my new K. So my new A, the slope is the same, but it flipped, which means it's going to be negative. Your H is how far left you went from 0, and we went 2 left. So H is a -2. K is up and down, and K is still 0. So it's going to be y equals A times x minus h plus 0. So this you could do again plus 2. Okay, let's look at a graph given. So if I give you a picture of something graphed, a parabola, can you write the equation in both standard and vertex? So vertex, here's what we need. We need A, H, and K. And it says let A be 1. So there we go. Okay, your vertex is right there. To get to that vertex, your H is left 1 and your K is down 2. So the vertex model we got, that's going to be the easiest. It's going to be y equals A parentheses x minus -1 squared minus 2. So x plus 1 squared minus 2. That's vertex form. Standard form, all you do to get standard form is you take x plus 1 and you expand it, times it by itself. X times x is x squared, x times 1 is x, 1 times x is another x, 1 times 1 is 1 minus 2, so it's x squared plus 2x minus 1. That is standard form. That is vertex form. So similar to the ones we did with ABCHK, same thing. Okay, these two questions. Fill in the blank to complete the square. then factor the quadratic polynomial. So complete the square. So your A is 1, your B is a minus 16. The C, they're letting you choose your own C, and you want to make it a perfect square. So to complete the square, you have to follow this template. Whatever your B is, you cut it in half. Then you times it by itself. So negative 16 cut in half is a negative 8. Negative 8 times itself. Negative 8 times negative 8 is positive 64. So then factor it. What will times give 64 and give a negative 16? We just did. It's going to be x minus 8, x minus 8, and that is x minus 8 squared. So it's easy when b is even. When b is odd, kind of sucks. So your a is 1, your b is 5, which is odd, and your c is, we'll find that out. So you got to do the same thing. You got to cut b in half. So you got to go 5 cut in half, which is 2.5, but no decimals. Let's leave everything in fraction form. Then you got to square it. So 5 cut in half times itself times 5 cut in half is going to be 25 cut into fourths. So the c you want is 25 fourths. Okay, now you got to factor it, and this will factor to a perfect square because 25 fourths is a perfect square. 64 is a perfect square. We can do square root of it. So if I cut this, if I factor this, it's going to be x plus plus, and it is going to be 5 halves. So if I do 5 halves plus 5 halves, that will be 10 halves. 10 halves is 5, so it adds to give you 5. And if I do 5 halves times 5 halves, that will give me 25 fourths. So not too bad, but crappy nonetheless. Okay, then solving equations. So let's look at 14. The moment that you see it's a degree 2 equation, a quadratic equation, there's going to be 2 solutions. Okay, there's 2 solutions because parabolas are reflexive. So here are your solutions. There's one there, there's one there. So you find your vertex, and there is one solution on each side of the vertex. So these are your zeros, these are your roots, these are the solutions when that equation equals 0. So first I want this to equal 0. So I'm going to minus 5 squares, minus 5 squares, and here's what I got. 1x squared plus 11x plus 28 equals 0. Okay, so now my a is 1, my b is 11, and my c is 28. Okay, a is 1. That's not bad. Let's see if we can factor that. So there is a chance that it will factor without too much work. Everything is plus, so it's going to be plus, plus. Okay, now here's the mission. What 2 integers will times to create a 28 and add to give 11? And those are 7 and 4. 7 times 4 is 28, 7 plus 4 is 11. So I'm going to go 7 and 4. And there we go. But now, so that's factored, but if it's an equation, if I'm solving, I've got to figure out what x is going to be for this really to be 0. So I know it's a quadratic because the exponent's 2, which means I'm going to have 2 solutions. One on each side of the vertex, and here are the solutions. X is going to be a negative 7, because if I let x be a negative 7, that will zero out this group. So a negative 7 add 7 is 0. And the other solution is a negative 4, because if I let x be a negative 4, negative 4 plus 4, that will zero that group. 0 times 0, 0. So if you're solving an equation, once you factor it, you got to figure out what is going to be substituted in for x to really make it end in a 0. So these are my two solutions. Okay, 15. I'm going to move this over, get everything on one side. So I'm going to add 8 v's. I am going to add 8 v's, but you cannot add v's with those, and you cannot add v's with those. So there are no like terms. So you put it in order, a standard form. You're going to go v squared plus 8v minus 12 equals 0. Okay, your A is 1, which we like. B is 8. And C is a minus 12. So if A is 1, let's try and factor it. So use your template. What integers will times to create a negative 12, but will add to create an 8? And you're drawn to like a 6 and a 2, but because you can make an 8 out of a 6 and a 2 adding, and you can make a 12 out of 6 and a 2 by timesing, but I don't think any way you arrange them is going to work. So it's got to be a negative 12. So one of them's negative, one of them's positive. If I go negative 6, add 2, that creates a negative 4. So no matter what factors you look at of 12, there's no way you can arrange them to add 8. So that right there means that your answers are not going to be integers. That means your answers are going to come from the rationals or the irrationals or maybe even imaginaries. So your answers are going to be ugly. So let's use the quadratic formula. If you cannot factor it, just go straight to the quadratic formula. So x equals negative b plus or minus the square root parentheses b parentheses squared minus 4 times a times c all over 2a. Okay, so you've already identified your ABC. You just plug them in where they go. Now it's only a couple more steps. Negative 8 plus or minus. This is how you're going to get your two answers. You got to do 1 plus and 1 minus. Square root. Okay, clean this up. Type this in on your calculator and always put this in parentheses. Or else your calculator is going to give you the wrong answer. Whoops, let's see. Okay. You should get 112. Now here's the problem. Square root of 100 is 10. Square root of 121 is 11. Square root of 112 is really close to square root of 100. It's between 10 and 11. So some decimal. Now no decimals. We don't ever work in decimals. So we're going to simplify this radical. So this radical is a square root. So let's take out all the squares. So 112, if you start pulling the squares out, 112 divided by 2 is 64. No, it's not 64. What's 112 divided by 2? 56. Two is done. 56 is like an 8 and a 7. 7's done. 8 is a 2 and a 2 and a 2. So here we go. 112 is really made up of 2 squared, 7 to the 1. So I got 4 2's, 1, 2, 3, 4. And I want to write them as squares because the square root undoes every square. So that means 2 is out. And it does this square, 2 is out. So here we go. Instead of writing the square root of 112, I'm going to write it like this. Negative 8 plus or minus. I took a 2 and a 2. Everything you take out, you times together, so that's really 2 times 2. So I've got 4 times the square root of, inside I just had a 7, all over 2. and you are actually dividing each of these by 2, and you can divide both those by 2. So negative 8 divided by 2 is going to be a negative 4. 4 divided by 2 is just going to be 2. So this is your answer. A negative 4 plus 2 square roots of 7 and a negative 4 minus 2 square roots of 7, or you can just write it as negative 4 plus or minus 2 square roots of 7. Okay. Here we go. Let's keep going. So let's solve this equation. So same thing, that catches your eye. That's degree 2. So there's going to be 2 solutions. It's some parabola, some quadratic. But let's get everything on one side. So let's minus 12r minus 12r. So those are actually 0 everything out. So you just have this 11r squared plus 12. Now your A is 11, B you actually don't have one, and C is the 12. So you cannot mix up your A's, B's, C's. And since A is 11, it's not 1, it's not a square root, so I'm just going to go quadratic form. I'm not even going to try and factor it. We're just going to go straight quadratic formula. So x equals negative b plus or minus square root b in parentheses squared minus 4 times A times C all over 2A. Okay, now I'm not even going to worry about this 0, but you can't forget the plus or minus. So let's clean up under the square root. Under the square root, you're going to have, if you clean all that up, a negative 528, and on bottom 2 times 11 is 22. Okay, move 1. Take the negative out. So you're going to have plus or minus imaginary square root 528. On bottom you're going to have 22. Okay, 528, let's see if that's a square root. 528. Okay, it's not. That's some crappy decimal. So here we go. 528. I'm going to divide. Let's see if we can divide that by something. Divide it by 4. If I divide it by 4, that goes 132. Okay, 4 is, that's a square right there. That's done. 132. I wonder if I can divide that by 4. We can. That's going to be a 4 and a 33. 33. Well, 33 is not done. 4 is a 2 and a 2. But 33 is just a 3 and an 11. So there's no doubles in 33. Alright, here we go. So that's a square, that's a square. So if I go square root of 2 squared, 3, 1, 11, 1, 2 comes out, 2 comes out, and everything you bring out you times together. So here we go. We've got plus or minus 4 plus, I'm taking this negative out, that's imaginary. Inside the leftovers are just 1, 3, and 1, 11, which is a 33. And on the bottom, you got 22. Okay, now this is a fraction, and these will actually simplify even further. 4/22. You can simplify 4/22 to plus or minus 2/11. Okay. Next, one of these tables describes a linear function and the other describes a quadratic. Which one is which? So you have got to see how fast they're changing. So 3 to 2, that went down 1. 2 to 3 went up 1. 3 to 6 went up 3. 6 to 11 went up 5. 11 to 18 went up 7. So it's definitely not linear. Your linear is a constant change. So let's go again. A negative 1 to a positive 1 went up twice. 1 to 3 went up twice. 3 to 5 went up twice. 5 to 7 went up twice. So your second change is constant. So that means that is the definition of a quadratic. Why? Because my second change is constant. Oh, my hand's starting to hurt. Okay, we're almost done. What about this guy right here? -1 to 4. That changed 5 times. 4 to 9. That changed 5 times. 9 to 14. That changed 5. So this one is linear because your first change is constant.